or looking at finding the period from a tangent that's just written in that general form. So we've seen the general form of sine, a cosine, or a sine b theta. We've seen cosine, a cosine b theta. We also have general form of tangent. Tangent is y equals a tangent b theta. Okay. The a is still your amplitude. So a is going to determine the, in a tangent, it's more like the stretch and compress of your curve, because we don't have the cycles like we did with sine and cosine. We just got those curves now. But a is still going to be your amplitude. B is going to still be your number of cycles. But in tangent, it's a little different how those cycles work. So that's what we're going to use the unit circle to look at. So in your unit circle, we looked at a couple of these in number 1. Like over here, we found, I'm going to zoom in on this unit circle a little bit. Over here, we found that the tangent was equal to 0, because 0 over -1 would be 0 here. Y over x would again be 0. We did this one on number 1. This one ended up being the square root of 3 over 3. This tangent would end up being 1. This tangent ends up just being the root of 3. And then this up here, well, what happens at pi over 2? Well, I do my tangent, which is 1 over 0. You can think about, well, what happens when I divide by 0? That's going to give me an undefined answer. And as I go down into the 4th quadrant, this answer right here is going to be the negative square root of 3 over 3 for my tangent. Because remember, it's just going to be this one, just reflected down to here. Same 2 numbers, just negative. This one's going to be -1. This one's going to be negative root of 3. But then you get down to 3 pi over 2. Well, what's going to happen here? -1 divided by 0. What's that going to equal? Undefined. So you got these 2 positions here where we don't have an output for tangent theta. So we put theta in, we put pi over 2 in, we put 3 pi over 2 in. Our answer is going to be undefined. So what I'm having here is I'm only getting solutions to tangent theta in between those 2 points. Right there and right there. So I can only get solutions to my tangent graph in between the pi over 2 and the 3 pi over 2, which is equivalent to half the circle. Well, if a full circle, it was 2 pi, that's what we looked at when we were doing sine and cosine. Sine and cosine, you can graph every single point as you go around the circle. Tangent only can graph between pi over 2 and 3 pi over 2, which is half the circle. So that's going to change our period a little bit. The b value now in a tangent is the number of cycles in pi, which now makes our period equal to pi over b. So it's not 2 pi over b like sine and cosine. Sine and cosine, you can go all the way around the circle and find your solutions. In tangent, you can only go half the circle until you get to those undefined points. Now you can also get solutions on this half of the graph. So after you've gotten your undefined, you again can find solutions to all these as you go into quadrants 2 and 3. So your period is going to be pi over b. Now the next thing is these undefined. These undefineds are going to create asymptotes on your graph. So that's going to create an asymptote because you have no solution at that position. And then this is going to create an asymptote right here. So as you start to graph tangent, you're going to start by graphing tangent at 0. And then as you get a quarter of the way into your graph, you're going to get an undefined mark right here. So when you get to pi over 2, that's going to be undefined because you can't divide by 0. So when you're graphing, like we looked at in that last problem, you can see that there's a solution at 0. And then as you go up and graph these solutions, when you get to pi over 2, you're undefined. But then you can get solutions, solutions, solutions. There's your next curve. But once you get down to 3 pi over 2, again, you get undefined. So at those positions, we have asymptotes, and your asymptotes are going to occur at pi over 2b. And at every plus or minus, whatever your period is, times the number of periods that occur. So we'll talk about that when we get to graphing. But you can find your asymptotes at, oops, I didn't mean to put pi over 2 pi, excuse me. Your asymptotes are going to occur at pi over 2b, excuse me. So you take that b value, take pi divided by 2 times your b value, and then you're going to get asymptotes at every plus or minus period length for the number of periods that you want to graph. And we'll just be graphing today 1, 2 cycles, so we can add on periods to find the next particular asymptote. So a couple of new formulas. If you have your number of cycles in pi, you can take to find your period, pi divided by b. Your asymptotes then are pi divided by 2b plus or minus the period times the number of periods. So n is just the number of periods that you would want to graph. Now, along the same lines, this b value, if you know the period of your tangent, your b value is simply just going to be pi divided by the period. So it's all the same, except now instead of being able to graph the whole circle, we can only graph pi. That's it. So we're going to find some asymptotes. So identify the period and determine where 2 asymptotes occur for each function. Show your work. So period, we simply just take pi divided by b, so pi divided by 5. And there's nothing else that we can do there. So there's our period. Our asymptotes, we do a pi divided by 2b, so pi over 2 times 5. And that's going to equal pi over 10. So one of my asymptotes is going to occur at pi over 10. And to find another asymptote, then I could take pi over 10, and I could add on the period. Okay? So that last problem that we looked at, let me just show you that last problem we looked at. There we go. So the last problem we looked at right here, this is where that first asymptote is occurring. Now I'm going to add on a whole period, because this whole cycle right here, I'm going to add on a whole period to find this next asymptote. So I'm going to do pi over 10 plus pi over 5 to find out where that next asymptote is. These graphs are all going to look the same. They're all going to have that tangent curve, but we're going to have the different asymptotes that we're going to start to see. So pi over 10 plus pi over 5, which is the same as, I'm just going to write it as a common denominator, 2 pi over 10, means that my next asymptote is going to occur at 3 pi over 10. So there would be 2 of my asymptotes. So pi over 10, 3 pi over 10 are going to be some asymptotes, and that's going to have a space of pi over 5 between them to complete that cycle. As we head into part B, we can find the period again. We take pi over 3 halves, which pi over 3 halves is the same as pi times 2/3. So this will end up being 2 pi over 3. So there would be my period. And I just use complex fractions, dividing a fraction, multiply by its reciprocal. Heading into the asymptote is going to be pi over 2 times my b. So 2 times 3 over 2 I'm getting kind of small on my 3 over 2 there, but 2 times 3 over 2, the 2's are going to reduce out pi over 3. So we're going to get pi over 3. Another way you can think of your asymptote, your first asymptote's always going to occur. It's going to be half of your period. That's what that pi over 2b is doing. It's just taking that period, pi over b, and cutting it in half. So 2/3, think of 2/3 as a fraction. Like if you're baking and you have 2/3 cups of sugar, you want to cut that in half, you'd only use 1/3. So that's what this pi over 3 is similar to, 1/3. And now let's find another asymptote. So we'll take pi over 3. There's your first asymptote. We'll add a period, which was 2 pi over 3. And our next asymptote would occur at 3 pi over 3, which the 3's will just reduce out. Our next asymptote could be pi. So we'd have an asymptote at pi over 3. Another cycle of 2/3 pi length is going to give us another asymptote at pi. So there would be our asymptotes. Now you could keep making asymptotes forever. Just keep adding 2/3 pi, 2/3 pi, 2/3 pi. So there's lots of different answers for these two. We just found 2 of those particular asymptotes.